Sling tension.
The basic objective of good rigging practices is to ensure that the load is safe and is as secure after lifting as it was on the ground. For safe lifting, you need to calculate the weight and center of gravity of a load. The weight, center of gravity, and location of lifting points of a load affect sling selection. By calculating weight and center of gravity, you ensure that the suitable rigging methods and slings are selected. If you fail to evaluate this, the load can flip or drift during takeoff. This module focuses on calculating the load factor and tension on the slings in order to properly select the rigging. To begin, let's go through the objectives of this module, which will give you a brief outline of what this module covers. After completing this module, you will be able to identify sling tension when using a single leg or multi-leg assembly. At the same time, you will be able to select a suitable sling type depending on the sling tension. Slings connect the load to a lifting device. Slings can be made of chain, wire rope, metal mesh, or synthetic materials. Before lifting a load from the ground, you must know the weight of the load. This enables you to select the sling of correct capacity. Sling tension is the amount of force or load on the sling, and the sling capacity is the maximum allowed tension to be applied to the sling. Let's take a look at a scenario with the following facts. There are 3 legs lifting the load. The total load is 24,600 pounds. The center of gravity is in the center. The slings are attached to round rings on the load. All 3 pick points are equidistant to each other. Pick points are equidistant to the center of gravity, and all 3 slings are equal in length. Let's calculate the share of load at each pick point. If we notice in the picture, all 3 pick points have a net load of 8,200 pounds, or what we will call share of load from here on. If we were to lift this load with the help from 3 separate cranes lifting simultaneously at each pick point, each crane would be showing 8,200 pounds of load on the crane scale for the vertical lift. Now, when using a single crane, we will rig all 3 slings to the crane's hook. To arrive at the tension per leg, we need the share of load at the lifting point, the length of the sling attached to it, and the height the crane hook is above the load. Let's take a look at the formula on the Journeyman Rigger's reference card, Panel 2, which helps us to calculate the tension on the slings. To calculate the tension, divide the sling length by the height of the sling times the share of load at the pick point. In this example, the sling length is 16 feet, sling height is 12 feet, and share of load is 8,200 pounds, as given in the picture.